Continuing on with Lesson 7 and subtracting fractions, we are now going to take a look at method 3. We're going to use the same problem, 1 3/4 minus 3/5. First, just like in the other two methods, you want to identify your original fraction or your starting amount, because in subtraction we have to know what we're starting with in order to know what we are going to take away. The starting amount here is 1 3/4. Step 1 is still the same. We are going to analyze for an estimate so that when we get to our answer we can check for reasonableness. How we do that is we take a look at our whole numbers and we perform the operation with those numbers. So our first whole number is 1, and our second whole number, there isn't a whole number, so then it would be 0. So our analysis for our estimate would be 1 minus 0, which would equal 1. And so our estimate for our answer is 1. So when we get to the end, we'll check our reasonableness against this estimate. Step 2 is we want to rewrite our mixed number as a fraction. If you have two mixed numbers, you would want to do that same step for both of them. But for this problem, we only have one mixed number, and a mixed number is a combination of a whole number and a fraction. How we would go about doing that is very similar to what we've done in the other two methods, but we would take and separate our two mixed number components, and this whole one we would rewrite as a fraction using that denominator 4 over 4, which we know is equal to 1. So we've just rewritten that 1 as 4 over 4. And then our fractional part of our mixed number stays the same. And what we would do is solve that. So that would be our whole amount of parts stays the same at 4, and we have 4 plus 3 parts. So 1 3/4 rewritten as a fraction is 7 over 4. Another way to think about doing this fraction or rewriting our mixed number as a fraction is you take your denominator, which is 4, you multiply it by your whole number, which is 1. So we did 4 times 1, and then we add the amount of parts on the top. So this is like saying, okay, my whole's 4, I have one whole, which is 4 parts, plus the other 3 parts of that second incomplete whole, which also gives us 7/4. So we have our 7/4. We've rewritten our mixed number as a fraction. And then we finish our equation with subtracting 3/5. Step 3 is renaming our fraction so we can create like units, because as we have it now, we have fourths and fifths, and that's like subtracting students from teachers. And before we do that, we need to make sure that they're all alike by renaming them. So I like to draw my parentheses to keep track of where all my parts are. And the way that we've talked about creating equivalent fractions is that we have to multiply by 1, because the only thing that keeps our fraction the same amount of parts is multiplying by 1. But we can rename that 1 by using the denominator of the opposite fraction, which is what our conjecture in class says. So I've reworked and kind of laid out the framework for renaming my fractions. And if we use a conjecture from class, we say we multiply the top, the numerator, and the denominator by the denominator of the opposite fraction, which is 5. So I would rename my 1 as 5 over 5, which is also equal to 1. And then for 3/5, numerator and denominator multiplied by the denominator of the other fraction, which is 4. So I would rename my whole 1 as 4 over 4. Then we would solve for our equivalent fractions. My new denominator for 7/4 would be 4 times 5, which is 20. So I've created smaller parts in my whole, and I have 7 times 5, 35 of those parts, which if we go back and check this fraction against our original 1 3/4, we know that our numerator is bigger than our denominator, which is telling us we have at least one whole, which is also confirmed by that mixed number up top. It's always good to go back and check for the reasonableness after you've done quite a few operations or equations within a problem. Now let's move on to 3/5 and finding that equivalent fraction. My number of parts is 5 times 4, so I've renamed fifths to 20th. I've made smaller parts, and I have 3 times 4. I have 12 of those parts. So I have renamed 3/5 to 12 20ths. The final step is to solve and simplify. So my equation now is 35 20ths minus 12 20ths. When we are working with addition and subtraction, our whole, or the amount of parts in our whole, stays the same. My original whole here has 20 parts. The whole that I'm subtracting also has 20 parts, so my answer also needs to have 20 parts. Now I started with 35 parts, and I'm taking away 12 of those parts, which leaves me with 23 total parts. So my answer is 23 20ths. Now the simplify is where we need to go. If we look at this and our conjecture, our numerator is bigger than our denominator, which means that we have a whole here. So I can rewrite this 23 20ths to show my whole. So I can take out 20 parts out of that 23. So I have 20 over 20, which is also equal to 1. And then I am left with 3 parts after I take those 20 out. So I'm left with 3 parts out of a 20-part whole. So that would equal, I have my one whole, my 20 out of 20, and then I have 3 20ths left over. So my answer to the equation 1 3/4 minus 3/5 is 1 3/20. Now I go back and check the reasonableness of my answer. I was shooting for my estimate of around 1, and I can see that 1 3/20 is near 1, so my answer is reasonable.